Alright, hello everyone. In this video, we're going to be learning about the binary search algorithm using Python as an example. Alright, so let's try and first understand what the binary search algorithm is. First of all, it's a sorting algorithm, meaning it's an algorithm that let us find something in an array. So let me just try and here open the drawing tool. Right, so imagine we have an array like this, and let's say this array contains let me try and separate the elements. Three, 4, 5, 6, 7, 8. Let's say this array has 8 elements in it, and they are all indexed, so 0, 1, 2, 3, 4, 5, 6. All right, so sorry, it has 7 elements. 1, 2, 3, 4, 5, 6, 7, 7 elements. All right, so this array, let's say it's an array that contains some kind of information, or like let's say this array contains numbers. All right, let's say like we have 72, 51, a bunch of numbers. We have an array that contains numbers. All right, so we have 13, 7, 96, all right, 0 and 10. And let's say we are given a number 7, and we are asked at which index is the 7 located. All right, obviously by looking at it, we know that the answer is 3. The way that is commonly used is a linear search, meaning we start with this element, and then if we didn't find a 7, we move on to the next one, and then to the next one, and so on and so forth until we find the 7. Now the problem, now this is a very good way of solving the issue using a linear search algorithm, but this could be problematic if we have a large array. Let's say we have an array that contains 1 million numbers, and we're asked to find the index. Doing a linear search might not be the smartest and the fastest way of figuring out where the 7 is located. This is where binary search algorithm comes in. Let me try and explain the binary search algorithm for you. Now we have the same situation, given a 7, and we are asked to find its index. Now instead of a 7, let me try and change this number here. All right, like this, and let's say we are asked to find the location of the 51. All right, the 51. The binary search algorithm, what it does is it starts by cutting the array in half. So we know that we have 7 elements. If, what is this? Is the color? All right, so we know that we have 7 elements. We divide by 2, all right, and we are given 3.5. all right, obviously we cannot loop through 3.5 of the array, so we'll just round it down to 3, and we'll have a remaining of 4. So what it does is it starts and it cuts the array in half. All right, cuts it in half, and then it checks here what the number is at index 3. Obviously it's a 7, and before doing that, because if we do this, then we have no idea if the 51 is before or after, because the numbers are shuffled. So what we start by doing is we sort the array first. We sort the array, meaning we put the numbers in order, so it becomes 0, 10, 13. Hold on, let me try and Okay, sure, I'll just do it that way. 0. So this becomes, I'll put it on top so that you can understand a little bit better. This becomes a 0. This becomes a 10. This stays 13. No. This becomes a 7. My bad. This becomes, I didn't see the 7. A 7, 10, 13, and this becomes 51, and this becomes 72, and finally this is 96. So now when we cut the array in half, obviously we don't have even sides because this has an odd number of elements in it. But when we cut the array in half and then we try and compare 51 with 13, we already know that 51 is greater than 13, so we can disregard the entire left side of this array. Then what we do, we cut the other side in half. All right, obviously this is now this is an even number, so we'll just take this number right here, which is now a 51, and we found a solution. All right, so by cutting the array in half, so let's say instead of a 51 we were looking for a 96, we would say, okay, 51 is less than 96, we disregard this part of the array, and then we do the same thing here. We cut it in half, check the left side, no, this is smaller, and whenever we have only one element left, obviously this is our answer. Now let's try to implement this algorithm using Python. So if you don't have Python, you go on Google or any browser and you type Python download. Here I'll download it for Mac OS, but you can download it for your operating system. I'll download Python 9.1. Right here. Alright, so I'll download it here, macOS 64-bit installer, and this should download quickly. Then you go through the installation, continue, agree, the usual stuff. In the meanwhile, we can look for an IDE. I'm gonna be using Visual Studio Code for this. I already have it downloaded, but you can download it anytime. It should work. All right. So now that Python is installed, we can close this, disregard the file, and then I'm gonna go here and open Visual Studio Code. Here I'm gonna be creating a new project. Hold on. Alright, so not this. What is this doing here? Alright, so you create a new file, and we'll do Control S to save it, and then we're gonna be naming it binary dot, and the extension has to be pi. Now let's find a location. I'll save it I'll save it in my desktop for now. Format. Okay, so hold on. I'll just select Python here, and I can disregard the extension, and it's gonna automatically save it as a .py file. All right, so now let's increase the size here, and perfect. So all right, so this should be good, so we can start coding already. Let's just print hello world, just make sure everything is working, and save it. Command save or control save for Windows. I will open my terminal, go into my desktop and type in python binary.py and allow access, and it printed hello, so we know everything is working just fine. Alright, so we can start coding our binary search algorithm. So naturally we want to create an array object, and I'm having a little trouble here. Alright, so we'll just create an array, and then we can input some numbers. They're gonna be 9, 82, 32, 55, and then we'll create a function, so define, and then here we'll call it binary search. It's gonna take an array as an argument, and obviously we're gonna pass in this array. So first we're gonna be creating a sorted array variable. We're gonna make it equal to array dot sort, and then here r. This should do the trick, and then binary search, and then we're passing the array, and here, just to make sure, we'll print the sorted array. Control save. I think, alright, so I made a really dumb mistake. I know obviously we cannot sort the array directly, so it's list, it's not array. So list.sort should do the trick. And okay, so here the right way of doing it is to use the sorted function, which is going to sort our array for us. I think I have a video explaining how to create your own sorting function on the channel. You can go check it out. And now we save it and we run it, and we have our sorted array. So once the array is sorted, we have to go through the division part. Now the division part, we could either do it using recursion or using a while loop, and I'm gonna be using a while loop for simplicity. Let's create a tracking variable, and we'll call it n. No, I'm not sure I'm gonna put it inside the while loop, but we'll figure it out while we go along. So what we want to do is we want to cut the array in half. So we need first to know the length of the array. So we call it L, or okay, just L equals length of our array. And now let's print L for now. Let's comment this out right here and save it, and then run. It gives us 7, so 1, 2, 3, 4, 5, 6, and 7. All right, perfect. So what we're gonna be doing is, let's try and think for a little bit. If the number is odd, when we divide by 2 and then floor it, it's gonna give us the number exactly in the middle of the array. So if we divide by 2, 3.5, floor the value is gonna be giving us 3, and 3 is the number exactly in the middle. All right, and what about if we have a number that is even? Then if we have 8 divided by 2 is going to be 4. It's going to give us one number closer to the end of our array. All right, perfect, no problem. So what we're going to be doing is create a while loop, and then first we have to find the middle index. It's going to be equal to L divided by 2, but then we would need to floor it. Okay, so in Python we have something that is called the floor division. We do a double divide sign, and this is going to automatically floor the number for us. And so what we're going to be doing is we're going to first check if array index middle index, and then here we have to find we have to create the number that we're looking for. So this is target, we'll call it target, and we'll create a target that say is 32. And so we'll say if array middle index is target. So if we already found it, what we can do is we can do print, and then here found number, and then we can say convert it to a string. The number obviously is target, and then we're going to be saying at index, and then obviously we're going to add the middle index as our index, and then we're going to simply break out of the for loop. Now if this is not the case, we need another if statement. So if here the array and then middle index. So no, let's say if the target is greater than middle index, what we're gonna be doing is we want to loop again, but through the second part of the array. Alright, so what I'm going to be doing is I'm going to be using recursion. I think I would like that way much better than using a while loop. And so what I'm going to be doing here is I'm going to be going back, and let's sort the array before let's take all this code, Control X, and take it outside of the function. Alright, copy, paste, and then what we want to do is add a second parameter, which is the length of the array. What we're going to be doing here is if target is greater than this, we're going to run the binary search function again. As for the array, what we're going to be passing is let's create a new array variable. So this is the new array that we divide in two, and we're going to be passing is going to be equal to array, and then the start index should be here, should be the middle no, not the value, but only the middle index. All right, so let's say the middle index is the length divided by 2, so in this case we start at 3, so wherever the middle, and we want to pass in all the way to L minus 1, because otherwise it's going to be it's going to return an error, index out of bound exception, something like that, and we don't want that. So we're going to passing the new array as a function for the array, and the length is simply going to be len of new array. Now we're going to be doing the opposite for here. Hold on, Control C. Let's paste it. Messed up. Do it again. Control C. Control V. Let's shift back a little. Now if target is less than array, and then so in this case we'll simply start at 0, and go all the way to middle index array. Alright, so in theory this should do it. Now let's test it out and see if we find any errors. Alright, so we do have an error. It says invalid syntax. I think the parentheses is what Python is not liking. This is JavaScript, or is not really Python like. So let me just remove these parentheses, and I think it should work just fine after that. Control save. Just try and run it again. Still have the error. If target is less than array. Hold on. Alright, so there's a couple of mistakes. First, there's a semicolon here that has nothing to do with Python. Here we have to find close the parentheses and remove this break, because we're now using recursion and we're no more using while loop. So we run this. Let's clear our terminal. Try and run it again, and we have a new error. It says name error is not defined, line 5. Okay, so here it has to be sorted array to get the initial length. Let's try it again. Name error is not defined. Okay, so here we have to start with sorted array, and here in our sorting we have to pass in our array. Let's save it, clear, run again. Okay, binary search takes exactly 2 arguments, only 1 was given. And where exactly is that? Okay, okay, here we have to pass in the initial length. Alright, string and ints objects cannot concatenate string and integer object. Okay, here we also have to convert this one to a string. Save it, run. Found number 32 at index 3. 0, 1, 2, 3. Alright, so it seems like our binary search finally worked. We were able to find this 32 using binary search algorithm. Alright, so this is how the binary search algorithm works in Python. I hope this video was useful for you guys, and we'll catch you up in our next tutorial.